right, so now we're going to continue with our wrap-up of lesson 4.3 on triangle inequalities. So in class today, we had 3 conjectures that we needed to determine from our investigation. The first one was the triangle inequality conjecture, and that says that the sum of the lengths of any 2 sides is greater than the length of the third side. The second investigation, we found the side angle inequality conjecture. In a triangle, if one side is longer than another side, then the angle opposite the longer side is larger than the angle opposite the shorter side. And then our last investigation, we found the triangle exterior angle conjecture. The measure of an exterior angle is equal to the sum of the measures of the remote interior angles. Some of you were trying to figure out how would we say the 2 interior angles, but not the one next to the linear pair. So that's how we say it, the remote interior angles. So let's take a look at how we can use these conjectures to help us solve problems. All right. Get the pen to work for us here. Let me go with a bright color. All right, so for example, if we want to arrange the sides in order from least to greatest or greatest to least, we don't necessarily need to know the exact measurements of the sides if we know the measurements of the angles. So taking a look at this triangle on the left-hand side, the first thing we need to do is figure out the measurement of the angle opposite side A. And we can do that using the triangle sum conjecture. Add the 2 angles we have, which is 105 degrees, subtract that from 180, and that gives us 75 degrees. Trying to change this color again. We really want this blue one. All right. So now that we know the 3 angle measures, I can use the conjecture that states the side lengths are basically going to correspond with the angle measurements. The largest angle goes with the opposite side. So that means side A is the largest side. Then the next biggest angle would be opposite the next biggest side. And then finally, the smallest angle would be opposite the smallest side. So in this particular example, ABC would be the the order of the sides from greatest to least. Now what happens if we have 2 different triangles? Okay, well we can still use this theorem to help us out. In addition, we can use the isosceles theorems that will help us determine the measurement of the 2 sides. So we already know in an isosceles triangle that the base angles are congruent to each other. So what we want to do is say 180 minus 30, and that gives us 150, which we're then going to split between the 2 angles. So each angle is 75 degrees. Now notice that the base of the isosceles triangle happens to be a congruent side of another isosceles triangle, and we have the letter B for one of those congruent sides. So that means we have the letter B for the base of the isosceles triangle. Those 2 sides are congruent, so we can use the same variable to represent them. All right, and then using, again, some isosceles theorems, we know that the angle opposite B would be 72 degrees. So then 72 plus 72, or 72 times 2, however you want to do it, would give us 144 degrees. Subtract that from 180, and you're going to get 36 degrees for that little angle in there. So we know that angle C is smaller than, angle opposite C is smaller than the angles opposite B. So we know that C is smaller than B. And then going back to our first triangle, we know that A is greater than B since the measurement opposite A is greater than the measurement opposite B. So again, the order from least to greatest would be A, B, C. Doesn't have anything to do with being alphabetically correct, it just has to be that mathematically that happened. All right, so Let's take a look at some other types of questions we can use our theorems for, our conjectures for. Now before, when we talked about solving for a variable such as r, we could have used the linear pair conjecture and figured out the measurement of this small angle here, and then used the triangle sum conjecture to figure out what the sum of those two angles, subtract it from 180, and then we'd figure out r. That will work. So if you forget this inequality measure, then you can go back to the very beginning of what we've done before. But if you can remember that the exterior angle is equal to the sum of the remote interior angles, then you can just say that 130 is equal to r plus 58. And then using algebra, subtract 58 from each side, and you're going to get that r is equal to 72 degrees. All right, simple as that. All right, now let's take a look at a review problem. So this might use a little bit of our conjectures from today's activity, or just may use some conjectures we've already talked about. So let's first investigate what's going on here. We have a lot of missing numbers, so we need to find their measurements. And we're going to go from A all the way to H. We see that we have parallel lines. All right, and so that means we have 3 transversals we're working with. Notice that one of the transversals is perpendicular. So right off the bat, using our corresponding angles conjecture, we know that the measurement of angle A is 90 degrees. Now we could use the triangle sum theorem to figure out B, or we could use the inequality measure to figure out C. I'm going to go ahead and go with that. So 90 plus 22, C is equal to 112 degrees. And then using our linear pair conjecture, we can say 180 minus 112 degrees is 68 degrees. So we figured out 3 of them. Now remember, we have parallel lines going on here. So let's take a look at this line right here. It's a transversal. That means angle E is going to be congruent to angle B, because they are alternating exterior angles. So that means angle E is also 68 degrees. Angle C is going to be congruent to angle D. So angle C and angle D are going to be congruent to each other because they're alternating interior angles. So we have those measurements. Now we want to figure out what F is. Well, we see that it's an isosceles triangle. Let's clear off some of that a little bit here. All right, makes it a little bit easier to see. We see that this triangle up here is an isosceles triangle. So that means F is opposite one of the congruent sides, so that means the other angle is going to be opposite the congruent side as well. Well, we already know that angle D was 112 degrees, and we know that remote interior angles are congruent to the exterior angle, so that means the two F's added together is equal to 112 degrees, so let's divide that in half, split up what the F value is, and we get 58 degrees this time. So F is equal to 58 degrees. All right, and then using our rule about exterior angles equaling the sum of the two remote interior angles, I can add E plus F together to give me G. And E was 68 degrees, F was 58 degrees. So when we add those together, actually I think I made a small mistake in here. Let me double check really fast. 56, 112, yep, 56 degrees, not 58 degrees. There we go. Small mistake there. 112 divided by 2 is 56. So fix that everywhere we have it. Now we can add E plus F. 68 plus 56 is 124 degrees. So that means G is equal to 124 degrees. And then again, we know that this line that G is part of is a transversal to parallel lines. So G and H are congruent to each other since they are alternating interior angles. So if G is 124 degrees, it means H is 124 degrees. So again, combining all of these theorems that and conjectures that we've studied from chapter 1 through chapter 3, chapter 2 and 3, well actually we didn't do 3, so chapter 1, chapter 2, now chapter 4, we're able to solve these complex problems. We're getting more and more detailed and able to figure them out. So make sure you do your suggested problems. That way you are well prepared for your quiz on Wednesday. It will be on lessons 4.1, 2, and 3. Come see me during the breaks if you have any questions.